So it will have angular velocity omega naught. Okay, that what is that omega naught? We know from rotational mechanical energy. From there we can apply it. After collision, this rod will swing back to an angle 30 degrees with respect to horizontal. I'll make one small diagram so that it'll be easy for you to understand. So this rod, so what it does, it will swing back. So immediately it will acquire an angular velocity how much? So let it be omega 1. Then it will swing back to this position 30 degrees. And the meanwhile, what happened to block will acquire a velocity, say v2. And it will slide. By the time when it reaches here it will have the normal contact will be twice of that one. So here you put it normal contact, right? N2, here the weight M2G. Later all other things we will add into the problem. To an angle 30 degrees from the horizontal. Okay, get into the problem now. So it must have here velocity. Some V you write it or V3. We have to discuss the problem. First, how to get omega naught. This will be half into ml square by 3 omega naught square by 2. Decrease in kinetic energy should be equal to, increase in kinetic energy should be equal to decrease in potential energy, mgl by 2. M1, it is M1. No? Where M1, what are the symbols? M1 equal to M, M2 equal to capital M. Omega naught equal to 3G by L. Then with this, we'll apply conservation of angular momentum. About what? About point P. About point of suspension. O, you write it. LOZI equal to LOZF. We do mistake of writing here conservation of linear momentum. You should not apply. An impulse will act here. But in exams, I think so, like the moment you say collision, no, you start thinking, but you have to control yourself. Huh? So this should be equal to initial angular momentum, M1.
That should be 60 degrees, sir. That should be 60 degrees, sir.
If the rod after collision rotates to an angle 30 degrees from the horizontal, okay, this will be 60 degrees. From the horizontal, no? Rotates to an angle 30 degrees from the horizontal. I think the question itself a little bit.
Even in the diagram, he mentioned 30 degrees, sir. So the diagram is correct only.
Oh, okay, that diagram is correct, but the explanation should have been rotates to an angle 60 degrees from the vertical. It should be. I think that will be more meaningful, because it will swing from here, no?
Yes, sir.
That one. Okay, let it be. I'll retain that one. So the angular momentum. So this should be called initial angular momentum omega naught equal to final angular momentum omega. This should be the negative sign plus angular momentum of the block mv2l. I have relations between omega naught value we know it. Omega and v2 both are unknown. So what we do is we'll go for quotient of restitution formula. E is equal to, but the collision is telling elastic here. The block after collision moves on smooth vertical circular track. We didn't say anything about collision. Okay, we'll see further. Okay, this will be equal to E2 equal to V2 minus of L omega 1 into L omega naught minus 0. Let's come to the block here. The rod after collision rotates through angle 30 degrees. I think, can we get this omega 1? Omega 1, I should write. Can we get that omega 1? Applying again conservation of mechanical energy, this should be equal to half m1 L square by 2 omega 1 square should be equal to m1 G L by 2 1 minus cos 60 degrees. Omega 1 will be 2 3G by 2L. Okay, we know omega 1, we know omega naught. I'll get the V2. I think no need of this. Okay, anyway, we have just wrote it because collisions we are learning. Quotient of restitution for the rod and particle. We can, if we ask, find the quotient of restitution, you can work out here. There's the only purpose why I brought equation 3. Put this equation 4. And then afterwards, the ratio of masses, M1 by M2 is what being asked. Can we bring the V2 from here? Applying conservation of mechanical energy. On the block at point C, it's 1/3 on point C. Yeah? I'll make some changes. Till here, no, it is. Point C is here. Here it will exert a normal contact. And what is this normal contact is equal to 1/3 of its weight. So what is the use of this? NC should be equal to mg by 3. So then NC should be equal to mvc square by r. What is the length here? Okay, L by 2. So this will become mg by 3 mvc square by L by 2. This is 2. So therefore VC should become equal to
root GL by 6.
Root GL by 6. After getting this V3 will write it. Then I'll apply between these two. So then applying conservation of mechanical energy, M2 V2 square equal to mg L by 2, M2 L by 2, M2 GL by 2, M2 V3 square. 2 get cancelled, so V2 is equal to GL plus V3 square, or GL plus GL by 6, 7 GL by 6. So we know value of V2, then we know value of V1, then we can get that ratio.
K will be 2, sir.
K will be 2. Okay, yeah, fine, good. Some different ideas here. If I ask you quotient of restitution between the rod and the block, you can find out. That's what I brought equation 3. So whenever that rod is there, no, rod collides with that one. So